Tribology is a study of interaction of surfaces in relative motion, include friction, lubrication, and wear. Type of fluids: Newtonian fluid has a linear stress and strain relationship, for example saline. Non-Newtonian they do not have the same relationship, for example synovial fluid. Friction is resistance of motion of a surface sliding over each other. This converts kinetic energy into heat reduced by lubrication. It is proportional to the load and coefficient of friction. It does not depend on surface area, but it does depend on the actual surface area. At this point, you should draw a diagram of asperities. Coefficient of friction: article cartilage is less coefficient of friction than ceramic on ceramic, then comes metal on metal, and then comes metal on poly. Regarding lubrication, it's a process to reduce friction. A fluid is interposed between the two surfaces which reduce the friction. Lubrication can be of fluid film or boundary. Boundary is where contact between the asperities is there due to the roughness. Roughness depends on the asperities' height. They are separated by lubricant, small lubricant monolayer, and which try to prevent direct contact. The lambda ratio, which is fluid film thickness divided by surface roughness, is less than 1 in boundary lubrication. Then comes fluid film lubrication, where the lambda ratio is more than 3. Usually happens in low load and high speed. It also happens in hard surfaces. Regarding the types of lubrication, further down it can be squeeze film, weeping, boosted, elastohydrodynamic, and microelastohydrodynamic. Squeeze film happens when the patient stands still and parallel surface get closer, produce a hydrostatic pressure from compressed film of synovial fluid. Weeping believes that articular surface acts like a sponge. When pressure is applied, fluid extravasates out into the joint surface. Boosted low molecular weight synovial components are pushed into the articular surface, leaving concentrated hyaluronic acid into the joint. This is called boosted. Elastohydrodynamic considers articular surface as elastic to increase the surface area. This happens during weight transfer or toe-off stage of the gait. Fluid is pushed along. Microelastohydrodynamic considers the asperities as elastic and can be deformed, increasing the surface area.